Good evening. My name is Mushiwidi Matabata, and tonight I'll be presenting on TPG3700 project. The chosen road for this particular project is the NTSHONDWE Road in the KwaZulu Natal. The selected road connects to Itala Reserve in northern KwaZulu Natal. Due to the road reaching its maximum lifespan, it is crucial to undertake an upgrade. During the planning phase, two main factors were taken into consideration. Firstly, safety is a significant concern as gravel roads can be dangerous to drive on, and they also prone to mud during rainy season that may lead to commuters facing risks of accidents, delays, vehicles getting stuck. By upgrading the road, safety can be improved by creating a smoother driving surface and reducing the likelihood of accidents. Secondly, there are economic benefits associated with upgrading the road. Enhancing the road can improve access to businesses and reduce transportation costs, which in turn can lead to increased economic activity, job creation, and an embraced traveling. And an enhanced traveling for the game reserve visitors. The next slide is the software that was used for this project. The software that I used was the Civil Designer because the Civil Designer is a specialized software application specifically crafted for the engineering and design sectors. It is primarily employed in the creation of top-notch designs with a particular focus on road and infrastructure development. The software is specifically designed to offer advanced functionalities for tasks such as geometric design, hydraulic analysis, stormwater management, surveying, and construction documentation. Its purpose is to support professionals in generating high-quality designs in this field. Now, the next slide speaks about the survey data. The survey data for this road. The chainage 0 and chainage 3 500, the X and Y coordinates are given on this survey data. Now this next slide is just a screenshot of the road design data obtained from the KwaZulu-Natal Traffic Department. The next slide is the pavement structure design. The TRH4 Table 16 and Table 22 has been referenced to for this NTSHONDWE Road CBR design. Now the next slide, the pavement structure design continued. The final CBR results. The design subgrade for this road is 8.5%. Now the proposed subgrade layers. The CBR design falls within this range of the CBR table. The pavement design, the road layers listed below will be considered satisfactory. Now the road reserve requirements, TRH26 and TRH16 has been referred. The road reserves are typically 30 meters and range from 25 to 40 meters. The adopted road reserve is 25 meters. Now the next slide is a cross-section of the road indicating the different types of layers of this particular road. Now this next slide is just the steps that were followed to make inputs to the software. Like for example, step 1 was to set up the size and scale of the drawing page in CAD mode. Use the A0 page size with a scale of 1:100. Create a new DTM file in terrain mode. Import survey data in survey mode. Make sure the CSV file created has XYZ columns selected. Step number 4 was to model the imported survey data, triangulate it, and activate the contours for better visibility. Step 5, in CAD mode, add a chained line along the alignment of the road. Step 6, ensure that the minimum horizontal curve radius meets TR17 Table 3.21 standards with a minimum radius of 210 meters. After this step, convert the center line to a polyline. The next slide is just a continuation of the inputs to the software. The next slide is also still continuation of the steps that were followed. Now this next slide is about geometric design manual calculations. TRH17 will be referred to for the geometric design of the road. Now for the horizontal alignment, I used TRH17. The design speed was found to be 80 kilometers per hour, the actual speed being 70 kilometers per hour, and the minimum curve radius 210 meters. Vertical alignment, as per TRH17, the minimum curve length is 140 meters. The minimum K value for the crest curve is 43, and the minimum K value for the third curve is 25. Now moving to the manual calculations for the vertical curve. The vertical curve, the beginning of this vertical curve, the chainage of the beginning of the vertical curve was found to be at 382 meters. The beginning of the vertical curve, the elevation thereof, was found to be 826.785 meters. The curve length, 350 meters. The first grade, 5.517. The second grade, 6.878. The elevation of the point of intersection, 817.130 meters. The chainage of the point of intersection was found to be 557 meters. The elevation of the end of the curve was 829.167 meters. And the end of the curve, the chainage of the end of the curve was found to be 732 meters. Now for the horizontal curve calculations. The beginning of the curve, the chainage of the beginning of the curve was found to be 165.084 meters, the radius 210, the deflection angle 25 degrees 47 minutes and 33 seconds. The point of intersection was found at 231.166 meters. The end of the curve, the chainage of the end of the curve at 259.618 meters. Now moving to the next slide, the drainage conceptual design. As an engineer, it is important to understand the inadequate surface drainage can cause the road to deteriorate as time goes on. Hence, it is important to design a stormwater drainage system, as this road has no stormwater drainage systems. So the upgrade design will need to incorporate a stormwater drainage system. Now, to implement a proper channeling of stormwater, a V-drain shaped curb for the outer shoulder has been selected. This choice will assist in directing water away from the surface of the road. Now, this is just a picture of the proposed V-drain outer curb. The next few slides are just the screenshots taken from the software. The first one was after setting up your drawing page, you import your survey data. The next one, the imported survey data, the screenshot thereof. This one is just a triangulation of the terrain. Inserting of the road horizontal alignment. I have inserted the data graphically so. The next one, for the design speed of 70 kilometers per hour, minimum curve radius of 210 meters was adopted as per TRH 17. Now, in conclusion, to summarize, then Tondo Road will undergo the aforementioned modifications. The following fundamental components have been implemented for this particular road. The road length for the road is 3.4 kilometers. The adopted design speed was 80 kilometers per hour as per TRH 17. The operating speed at 70 kilometers per hour. The California bearing ratio, an average of 8.5%. The pavement layers, the pavement structure is given as 40A wearing course, 150 millimeters G1 base layer, and a 300 millimeters C3 sub base layer. So as a result of these particular modifications that I just highlighted, the tourists and residents of the KwaZulu-Natal, the tourists and residents of the village will experience improved traffic flow when commuting between the central business district and the game reserve. Additionally, upgrading and widening the road will contribute to a reduction in road accidents. So it is important for the local municipalities and authorities to prioritize the regular maintenance of this particular road to ensure that the road functions optimally. Thank you.